Hi, and welcome back to Measures of Dispersion class. So in today's video, we're going to look at measures of dispersion. So when we talk about dispersion in statistics, okay, we are talking about how spread, or vary a data is from its mean. How spread or vary a data is from what? Its mean. Alright. So the idea here is that if data are close to their mean, then we will say that it is close, and then it will reflect what a perfect what data about the mean, or the average reflects a perfect what data, right? But if data are spread out of the mean, then we say that the data or the mean actually doesn't reflect what the data that we are taking into consideration. So that is measures of dispersion. It's also called it what as what variation. So how spread out or vary a data is from its what mean. So if data are close to the mean, we say that the mean actually represents what data that we are taking under consideration. But if the data are varied or far away from the mean, then we say that the mean actually is not a representative of the data under consideration. So that is the idea about what measures of what dispersion. So to support this explanation, let's bring out some practical illustration about how data is spread out or varied from its mean. So let's say we were having these two products in the market. And in terms of their price changes, that occurred for particular period, 5 day period, let's say 5 day period, right? Let's say we have two products. The products were product A and that of what say product B. So these were the data that we recorded for. Product A and product B in terms of their pricing for a particular what period. So product A, we're having what 5, we're having 15. These are their price changes. These were their price changes. 35. We have here to be 25, and we have here to go 45. And for that of product B, we're having 20, having 35, 25. We have 20 here, and then lastly we're having 25. Okay, so for us to know how these products actually spread out or vary from their mean, let's see, first of all, we need to compute for what their mean or the average, right? So we'll say that to compute for mean from our class or idea on what measures of what central standard, you should be able to know how to compute a mean. So we say that mean of what the price of the product that was frequently changing in product A should be equal to the summation of what their prices, right? And then divided by what the number of prices we have taken under consideration, right? So when we add 5 plus 15, 35, 25, and then 45, you're supposed to get what 125. So 125 divided by what the number of prices here is what 5, and we do same here. Yet when you add all, you're supposed to get what 125, right? So we'll say that the mean of what B is what 125, and then divided by what 5. So what are we getting here? You're supposed to get what 25. So on average, the price changes was reflecting what 25. So here too is also what 25 dollars. Okay, so now what is happening here? You can clearly see that the two products in terms of their average is telling you that in terms of their average, the price changes was what occurring the same, but actually this won't actually help us to understand deeply how the data is in terms of even the spread or the changes that was occurring between product A and product B in terms of their pricing. So we'll go a step further to also to understand or take the discussion further to how spread or varied what this data was when the prices was what changing, right? So in that line, we're going to present this data in the form of what a graph, and we're able to know how the data actually spread out from what their mean. When we look at the surface from the mean, we wouldn't you conclude that in terms of price changes, they were what the same. But actually, it is not so. So let's look at the graphical representation of these two products, and then that will give us a fair idea or better understanding about how these data are spread or vary from what their mean of what 25. So I would say that for uh product A, these are the values. So we're having 5, 15, 35, 25, and then 45. So this is what I'm going to do. I'm going to represent them in the form of what? A line. I have this straight line. Okay. Let's say I have here to be 5. I think from 5 we have what? 15, then 25, and we have 30, 35, 40, 45. Okay, so I'm going to deal with what the product what A. So price change of 5 for product A. And we also have in terms of their frequency that I'm trying to put in combo was just what 1. And then that of 15 was also what 1. So on the same line. And then that of 25 to is actually 1. So we just have to pull it like that. And then that of 30, we have 30 here, no, so but we have 35. Okay, and then we have that of what 45. So 45 to something like this. So this was product A. You can clearly see that this one is a flat what kind of what data, flat kind of data. All right. Okay. How about product B? So product B. So using the same illustration here is what can happen. So we product B to, let's say we're having what 20, 35, or 20, 35, 25, 20, and then yes. So we can have as well 20 here, let's say 30, let's say 35. I think we're having 25 there. So 25. In terms of frequencies too, so we have what 1 and then what 2, right? So here I'm going to have what a long bar presenting 220, 2 in terms of twice of what 20. How about 25? 25 here was also what 2. So 25 in terms of frequency that we are putting on is what 2. Right? We have 30, but we have what 35. So 35 too was just 1. 35 is just 1. So now what is happening here? You can clearly see that from product A and product B in terms of their presentation on a graph is actually what totally different, right? Totally different. As in the case of what their mean, where it was the same. So you can clearly see that here the data are spread out, right? You can clearly see that with product B2, the data is actually spread out, or it has what we call in normal distribution. This should have been what we call heading towards data have been scattered or heading towards what the negative side of what the line and not moving to the positive side. So we have called this what a negatively skewed what distribution. So you see in terms of their spread or graphically, they are not the same. So this explains what the spread of what the data you want to what bring on board in that line. So once you're able to find the mean, you can conclude that once their mean are the same, actually the product price changes was what the same. In terms of their difference, you can clearly see that here from 20 to 25 was 5 here, from 25 to 35 it was what 10. So in terms of their difference to there is this what some differences. Here was 10 throughout, but here we have 5 and we have what 10. And these are the variations that will exist between the data. And that is the idea about what measures of what dispersion. So let's take note of that. So after knowing this, what are some of the important things that measures of depression bring on board for human beings to appreciate and use it in our daily lives? So one of the key important or significant issues about measures of depression here is that when we're able to determine measurability of what a data, it'll help us to be able to make what a reliability. So it says that measuring variability determines what the reliability of what the mean. But once you're able to know how spread the data is around the mean or close to the mean, we're able to what have some kind of what reliability. So there's what reliability of the data. There is what a reliability of what the data, reliability of what the data, because we can place the data around, all right, around the mean or close to the mean or far away from the mean. So reliability becomes key in that line. It also helps us to determine what the nature and cause of water. So we are talking about nature and what cause. Nature and cause of what? Nature and cause of what? The variation, in order to control the variation. So once you're able to determine how spread out a data is from its mean, we're able to know why there existed differences, right? And then once we're able to know that difference, then if it's a good or bad one, then we're able to find an appropriate way to control the variation itself. And then you can also use it for purpose of what? Comparison. Comparison purposes, comparison. So comparison also becomes key for us to also determine what the variation that exists among what data, right? So once you're able to compare set of data values, it help us become more efficient, right? So that we know that going forward, these are the kind of data we can use, and then these are the results going to give us at the end of the day. So comparability also becomes a key issue in here. So let's take note of that. So as always, we are going to discuss these measures of uh, uh, dispersion proper, but we're going to take it from two approach. We are going to look at the ungrouped way of what, or group data of calculating measures of dispersion, and later we look at the group uh, measures of what dispersion in that line. So we are going to look at the ungrouped, ungrouped what data for measures of what dispersion, the ungrouped data for measures of what dispersion. So under that, we're going to look at what range. We're going to look at mean deviation, and then we're also going to look at the variance, and lastly we look at standard deviation. Here too, you're going to look at in terms of their sample and then population. Those that have sample, just have to look at it, and then population to look at it in that line. So let's take note of that. Okay, so range in simple terms, let's start with the range. Range in simple terms has to do with what? The difference between what the highest value and then the lowest what value. So once you heard of range, we are talking about what the difference between the highest value and then the lowest what value. We use range in actually in a statistical what control processes, right? Mostly we use this in application level in business that makes use of this what kind of data, right? Statistical control processes. That's where range are actually perfectly used in that line. So range is actually the difference between the highest value and then the lowest value. So when we want to take this data into consideration, for example, this illustration that we use, what will be the range for what A? The range will have been that it should be the highest value, which is what 45, and the lowest value, which is what 5, and we'll have gotten what range of what 40. When we come to that of B2, what will have been the range? Range would have been what? The difference between the highest value, which is what 35, and lowest value, which is what 20, and we have gotten what 15. So that is the range between what data values. All right. So that is the range that we are talking about, the difference between the highest value and the lowest what value for both what group and then ungroup, for range having character for both group and ungroup. So that's that for range. So let's continue to look at what that of what mean deviation. So when we talk about mean deviation, per the name, it should be able to tell you what it means. When we talk about mean deviation has to do with what? The arithmetic mean of the deviation of what? Data values from what? The mean. The arithmetic mean of the deviation of the data values from what? Its what? Mean, right? The deviation of what? The data values, or the deviation of the absolute data values of what? From its mean. That's what we call what? The mean deviation. So here we know how to calculate mean deviation from our idea in measures of what? Central tendency, right? So to calculate deviation, we always say that D should be equal to what? The actual value minus what? The mean value. Is that okay? The actual value, or the actual data value, minus the mean value. So at the end of the day, once you're able to know the number of what deviations, you find the absolute values of these deviations and you find their mean. So mean deviation is the arithmetic mean of the absolute values of the deviation, right, from what it mean. Absolute values of the deviation from it mean. So for ungrouped data, for us to calculate what a mean deviation, we will say that MD for a mean deviation is always equal to the summation of the absolute value of what? X minus X bar being the deviation, and then divide by what? N, and then divide by N. This is for what? Ungroup what? Data, as we are discussing ungroup what? Data. So that's how we calculate mean deviation for what? Ungroup what? Data. So let's take note of that. So let's take an example to actually explain this concept better for mean deviation. So let's say we have this data, a sample profit figures obtained from what? A particular company, and then that's been from the year 2010 to what? 2014. And these were their profit figures that was shown from the year 2010 to what? 2014. These were the numbers in terms of their profit. So we're having what? 1. So in terms of, that's going to be the X value. We're having 500 for the year 2010. And then we're having what? 300. So 300, and come back to what? 700. Then we have 150. And then let's see, we have what? 800. So these are the data values of their profit from the year 20 what? 10 to 2014. Okay. So these were the so once you're able to get these data values, we have to calculate the mean deviation of what these values. So we will also need to calculate what we call our deviation, which is what? X minus what? X bar. Okay. So before we can calculate X minus X bar, we need to know the mean, right? So what will be the mean for this data? We will say that mean is always what? The summation of what the X values divided by what? The number under consideration. So what will be the summation? So when you add all these X values, supposed to get what? 2,450, and then divide by what? So how many numbers do we have here? 1, 2, 3, 4, 5. So from 2010 to 2014 is what? 5. 5 years what? Profit figures that we are trying to measure. So you're going to get what? 490 as what? The mean. 490. So once you get that, we're going to deviate the mean from what? These what? Values, right? So 490 taken from 500, you're supposed to get what? 10. Okay. Then 490 from 300, we are getting what? Negative what? 190. Then here you are getting what? 210. Here we are getting what? Negative 340. And here we are getting what? 310 in that line. So once you're able to get the deviations, you find absolute values of the deviation. But absolute means that if it is negative, it becomes what? Positive. If the positive remains what? Positive. So absolute value of 10 is 10. Absolute value of negative 190 is what? Positive 190. 210 is also what? 210. Negative 340 is what? Positive 340. And then positive 310 is what? Positive 310. So once you are done, you find the summation of what? The absolute values of the deviation, right? And when you do that, you're supposed to get what? You're supposed to get 1060. That is the sum. You're supposed to get what? 1060. You're supposed to get 1060 as a summation. 1060. Okay. So therefore, we say that our mean deviation for the profit from the year 2010 to 2014 for a particular company should be equal to what? the summation of what the mean absolute values of the deviation, which is what 1060, divided by the number, which is what 5, and we're supposed to get what 212 as the mean uh deviation of the profit. So the 212 means that on average for a profit, the mean deviation, or we deviate on average of what 490, we deviate in terms of our profit, we deviate by what 212 dollars. That's the meaning behind. On average, which is 490, the company deviated 212 profits, right? On average. So that is the meaning behind that. So this is how we calculate what mean deviation for ungroup data. All right. So let's move on to also talk about the variance. Here we look at it from what population and then sample. So variance for ungrouped data. So population, and then sample variance. Okay, so when we talk about variance, the variance also has to do with what? Variance, there is the arithmetic what? Mean of the square deviation from the mean. So we say that variance is the arithmetic what? Mean. So we say that variance is the arithmetic mean of the square deviation from the mean. So here we know square deviation of what the mean. So for population, let's start with population. For me to calculate what a variance for population, we say that always our deviation t is always what our x minus what our x bar. The variance is taking on that it is what the arithmetic mean of the squared what deviation, square deviation. So here the deviation, we're going to square this, right? And we find the mean of what such what deviation. So the arithmetic mean of the squared what deviation, right, from their what mean. So we find if it is population, this is how it's going to be capital what N. So in a proper way, we say that to calculate what the variance for population, we say that variance with a formula and a symbol, this should be equal to what? So we say it is what the summation of what the square deviation, right? And then divide by what? The number and account. So this is for population. This for population. This for what? Population. This for population. This is how we calculate what? Variance for what? Population. It is a summation of what? X minus x bar all squared divided by what? Capital N for population. But it is for what? Example, then we say that variance should be equal to what? Summation of what? X minus x bar all squared and then divide by small n. In addition, subtract 1 from what? The n. This is how you also calculate what? A variance for what? A sample. So let's take note of that. But that is for a variance. Variance and that of standard deviation also what moves together. So when we talk about standard deviation also has to do with what? The square root, the positive square root of what the variance. What is standard? When we talk about standard deviation in raw business application, standard deviation in relation to measure of dispersion, we say that always if the standard deviation of a particular set of data is small, then we say that the average actually represents what the data, and on that the data will be clustered close towards the mean, but the mean, or not be close towards the mean. So the smaller the standard deviation, the closer the data is around the mean. But the larger the standard deviation, the far away the data is from what? The mean. So there is the interpretation behind what? Standard deviation. It's actually the positive square root of what? The variance. So for me to get that of my standard deviation, the same word formula for variance, okay, I will say that therefore I will have to take what? The square root of what? The variance. So when you take the square root of the variance, what is happening? Then we're going to get what? We are going to get this square will cancel this square, right? This will cancel this. This also will cancel this for population and then sample. So we're going to get what? Our standard deviation to what? the square root of what? Summation x minus x bar for ungroup data all square, and then divide by what? N. So this becomes what? Population. Population. Okay, this becomes population. But if it is example, then the same thing. The square also cancel the square. So we have what? We have what? Summation x minus x bar all squared, and then divide by n minus what? 1. This is for what? A sample. So always, once you're able to get your variance, you just find the square root of what? The variance. That will fetch you what? Your standard deviation. So let's take note of that. Let's take note of that. It's not pass, so we'll take it off. I'll just use that to explain concepts for you to appreciate better. Right. So this is also how we find what the standard deviation for a set of what? Data. So let's take note of that. Let's take note of that. Okay, so let's use a practical example to explain the standard deviation better.
The data below are the wages paid by M&N company to its employees. So you have $300, $500, $600, $250, $450, $370, and then $150. You're asked to use the above data to find the variance and then the standard deviation for this company or for the company. Remember, this data is an ungrouped data, so we're going to find what variance and standard deviation for this data. So how do you go by this? Well, we first of all need to have a column representing what the data. So that's going to what? X, column X. So we have what? Our solution here. We're going to have what? Column what? X, sorry, X here. So that's going to include what? So X in $X is going to include what? 300, 500, 600. Then we have 250. Then we have 450. Then we also have that of 450. We have 370. And then lastly, we have what? 150. All right, so once you have a column for X, that's going to be so. And then we also find, since we asked to find what the variance, this is an ungrouped data. So to find the variance, we need to also to find a column for what? A column for X minus what? X bar. That is the deviation. Deviation is always what? The X values taking away what? The mean of what? The X values. I hope that is clear. All right. So in this case, you're going to have a column for what? X minus what? X bar. Right. So how do you find that X bar then? This is the mean of what? The data. So to find the mean, we always say that mean for this data is going to be what? Summation X divided by what? Since this is what? Data for what? Population, you are going to use what? The capital N. Because we were told that these are the data for the wages paid by M&N to what? This company. It didn't say part of it, it just said what? The data. So mean this what? A population was kind of what data for the wages that's being paid by M&N what company. I hope that is fine. So in this case, to find that of our mean, that's going to be what? The summation of the X values and then divide by what? The number under consideration. So we're going to have here to be what? 300 plus 500 plus what? 600 plus that of what? 250. Okay. Plus that of 450 plus that of 370. Then we have what? 150. And then divide by how many sets of data do we have in this particular case? We have what? 1, 2, 3, 4, 5, 6, 7. So we divide by what? 7. So when you're able to do the calculation right, you're supposed to get a total sum to be equal to 2,620. divided by 7 for the numerator. So, we're supposed to get a mean of what? 374.28. We have some figures in there. But for the purpose of this, I want to run it to the nearest whole number. So I'm going to remain the answer to what? 374, right? It is not always that we approximate to the nearest whole number. It's always going to be based on the requirement of what the question. So if you are required to approximate to the nearest, that's fine. But for the purpose of simplicity, that's why I'm approximating to the nearest whole number to do away with the decimals in that case. But where we are not told of that, you just must work with the decimals, assuming you encounter such situation. So once you're able to get our mean of 374, then we can find our column for x minus what? X bar. So let's see how we go by that. So in that line, I know my mean to be equal to what? 374. So I'm going to deviate it from these values. So when I subtract 374 from 300, I'm supposed to get what? Negative what? 74. When I do say 374 from 500, I'm supposed to get what? Positive 126. When I do same with the 600, I'm supposed to get what? That of what? 226. And that of 250, I'm supposed to get what? Negative 124, negative 124. Then 450, I'm getting 76. 370, I'm getting negative 4. And then 150, I'm getting negative 224. So these are the deviation goals. So you subtract the mean from the x values in that line. So once you're able to get the column for x minus x bar being the deviation, the next thing we want to find is to find what? A column for x minus what? X bar or what? Squared. X minus x bar or squared. So we're going to square what? The various what? Deviation. So the square of negative 74 should fetch us what? 5,476. That of 126, we should be able to get what? 15,800 and what? 76. That of 226 is supposed to get what? 51,076. That of negative 124 is supposed to get that of what? 15. This one is 51,076. Here you're supposed to get what? 15,376. That of 76 is supposed to get 5,776. Or we get what? 16. And then 224, we should be able to get what? 50,176. So once you're able to get a column for x minus x bar all squared, you then find the total sum. So what are we getting for the summation of what? These values? So when I sum all of them up, I had a total of what? 1,43772 as my total sum for x minus x bar all squared, right? So once I'm able to get this, then I can proceed to find what? My variance. So we said variance from group data. We use what? This symbol to represent variance from group data is supposed to be equal to what? Summation x minus x bar all squared and then divide by what? Since it's a population, we divide by what? N. I hope that is clear, right? So in this particular case, this is what we're going to do. We know that summation x minus x bar all squared is what? 143,720 So you can see here. So we have what? 143,772 divided by, so what is the number of what data under consideration? It was what? 7, or it is 7. So we have here by what? 7. Okay, so what are we getting as variance? So variance supposed to get what? 20,538.86 in 2 decimal places. So you are going to get this what value, all right? You're going to get, so this is the variance for the company, right? Which is the square root of the deviations, right? The arithmetic mean of the square deviations, right? Of the set of what data. So once you're able to get that of what that of the variance for the company, you can then proceed to find that of what? The standard deviation. So standard deviation, which is what? The positive square root of what? The variance, which is equal to the positive square root of the variance. So we say that our standard deviation to it is what? The positive square root of what? The variance. So here to the same formula, all right? So we have x minus x bar all squared and then divide by n. So we know summation x minus x bar all squared divided by n as what? This, right? The whole of what? This. So here you're supposed to get what? So in the form of what? A graph. You can clearly see that this is actually a bit of what? A small standard deviation. Then we expect that the data will be clustered around what? The mean, right? The mean of what? 374 in that line. But assuming the standard deviation was big or greater than that of, even heading towards to that of the mean, then you can clearly see that once you represent it on the graph chain, bye bye.